Hello, good morning everybody. Let me take you through FA4. Okay, so for the first question, right, it is asking you to explain the term in italics. So if you go up to the question, the only term in italic is weak bronzed base. So in this case, you have to split up the term, explain each part of the term separately. Meaning to say, you have to explain weak base. Okay, so for a weak base, you have to mention that it actually dissociates partially in water or solution to form OH minus ions. Okay, this part here, the key term is in water or solution, because if you dissociate partially without the water, it actually won't give you OH minus. So you need the water or solution. Next part, you will need to explain bronzed base. So for bronzed base, it simply just means it is a proton acceptor. Okay, so next time you're asked to define a term, if you see that there are actually two different parts to the term, please split up the parts, explain it separately. Okay. For part B, they say write an expression for the base dissociation constant. This part over here, the main thing is you need to recognize what is base dissociation constant. Okay, recognize that it is talking about Kb. Okay, take note that this is not the same as degree of dissociation. Okay, degree of dissociation is not the same as base dissociation constant. Okay, they are not the same. So for NH3, when you do dissociation, you will actually get NH4 plus and OH minus. Okay, and Kb is product over reactant, so you should have NH4 plus times concentration of OH minus divided by NH3 concentration. Take note that over here we do not write H2O below, because we know that this is a heterogeneous equilibrium. Okay, we leave out the concentration of pure liquid and pure solid. So H2O, we leave it out. Okay, moving on to part C. Part C asks us to calculate the pH of 0.02 mole per dm³ of aqueous ammonia, given that the Kb is 1.78 times 10 to the power of minus 5. So based on this, recall that you have a lot of equations, but we know that ammonia is a weak base. So when we talk about a weak base, that means to find the pH we will need to use weak base equation. Okay, use weak base equation. So as a quick recap, your weak base equation will be POH is equals to minus log square root of the Kb times concentration of the base. Okay, take note, how do we remember this? Weak base, so we have OH, and Kb, B for base and a base. Okay, alternatively, some of you may like to find concentration of OH minus first, and with the OH minus, it is simply just square root Kb times the base. Okay, take note that the difference between these two is simply just whether you took minus log on both sides or not. It is actually the same. Okay, so based on this, you just sub in the respective Kb given to you. The concentration is 0.02, and you can find OH minus concentration to be 5.967 times 10 to the power of minus 4. Then after that, you just take POH is equals to minus log of the OH minus concentration, you get 3.2. But the question asks for pH, so you still need to take pH is equals to 14 minus 3.2, you will get 10.8. So 10.8 will be your answer. Alright? Okay, we can move on to the next part of the question. Okay, question 2. This question 2, make sure everybody knows how to do the sub-question, okay? Because this question, you require you to state a trend. So based on this, let's take a look. They say that reactant A and reactant B react together to form product C. And you are given the mole ratio in front to be A, B, and C. Take note over here, you don't know what are the values, so you cannot say that A or B have more number of moles of gaseous particles, because from the ABC you don't know what numbers it is, so you cannot assume. Okay, but they tell you that the percentage yield of product C varies according to temperature and pressure as shown in table 1 and 2. So for the first part of the question, they are asking for table 1, okay, deduce with reasoning whether the forward reaction is exo or endo. Okay, so recall that every time we take a look at endo or exo, we look at temperature change, right? We look at temperature as the factor. So this part, indeed, we are given temperature. So you notice as temperature increases from 200 to 600, the percentage of product C also increases from 8% to 23%. So for this question, you can do it very systematically. Firstly, you just state the trend, okay? You need to state the trend to get 1 mark. So the trend is as temperature increases, percentage of product increases. That gives you your 1 mark. Then after that, it can also be very systematic. You explain temperature increase, then you explain product increase. What do we mean? Simply just means, okay, if temperature increases, we know that the equilibrium position will always favor the endothermic reaction in order to reduce the temperature by absorbing the additional heat. So take note, temperature increase favor endo in order to absorb the additional heat and to reduce the temperature. Okay, I hope everybody is clear. Then next part, you explain product increases. So when product increases, what does it mean? It definitely means that the equilibrium position must have shifted to the right. Okay, it means that equilibrium position must have shifted to the right. That's why the percentage of product will increase. So based on this, okay, do a matching. Matching simply just means it shifted to the right, and it actually shifts to favor the endothermic reaction. So we know that the right hand side is equals to endothermic reaction. Okay, so that means right hand side is just the forward reaction, so we know the forward reaction is endothermic. Okay, so in this case, the main thing is to do a matching like this. The right hand side is the endothermic reaction. Okay, then I will move on to the next part B. Okay. Okay, for table 2 is actually very similar to question 1. So this part, they are talking about with reference to table 2, deduce with reasoning whether the forward reaction involves an increase, decrease, or no change in the number of moles of gaseous particles. So let's just do a recap. When we are supposed to deduce whether there are more or less number of moles of gaseous particles, we always look at the pressure, right? Look at pressure change. So indeed, table 2 gives us the pressure change. So we know that when pressure increases from 1 to 3 atm, the percentage of product C actually decreases from 34 to 15. So again, how you would approach the question is very simple. Firstly, state the trend. So the trend says that as pressure increases, the percentage of product decreases. And again, you can split up the trend and explain. So pressure increases, you will explain it. And also product decreases, you can also explain. So let's go step by step. Pressure increase, it means that it will favor the side with less gaseous particles in order to reduce the pressure. So equilibrium position will shift to the side with less gaseous particles in order to reduce the pressure. So far so good. Next part, when product decreases, it means that the equilibrium position must have shifted backwards. Okay, shift backwards. That's why the product will decrease. Okay, I think it makes sense. When the equilibrium position shift back, the percentage of the product will definitely decrease. So now you have split up the trend to explain the individual terms. You can do a matching. Matching meaning what? Okay, let's do a recap. Matching simply means the equilibrium position shift left or backward, and it is in order to favor the side with less gaseous particles. That means the left hand side will be the side with less gaseous particles. Okay, so based on this, the left hand side or the backward has less gaseous particles. That's why the forward reaction will have more. Okay, so that's why the forward reaction will have increase in the number of gaseous particles. In all your explanation, please ensure you use the term gaseous. Okay, gaseous particles. Similarly for on top, gaseous particles. Okay, so with this we can move on to the next question. Part C asks you to state the optimum conditions, okay, in terms of pressure and temperature for the production of C. So in this case, optimum simply just means you want to produce as much C as possible. Okay, as much as possible. Okay, the product, as much as you can. So based on this, you just look at the tables given to you. Table 1, you have most product C when it is at 600 Kelvin, high temperature. For pressure, the highest amount of product C will be at 34% and it is at ATM 1, which means low pressure. So over here, your answer is simply just low pressure 1 ATM or high temperature 600 Kelvin. Okay, so with this, we can move on to the next part of the question. Question 3. Okay, question 3 requires you to draw some diagrams in order to visualize well what is happening. So one way to test for CO2 gas is to bubble into lime water. However, they tell us that the calcium hydroxide is only sparingly soluble. So take note, when you see the term sparingly soluble in questions, that means likelihood is they are testing you on ionic equilibrium. Okay, because this is where we see salts that are sparingly soluble. So over here, the scenario given is that you have an excess of solid calcium hydroxide shaken in 0.01 mole per dm cube sodium hydroxide to reach equilibrium and then filtered. Okay, so take note, 25 cm cube of the filtrate is required to neutralize 20 cm cube of 0.05 mole per dm cube hydrochloric acid. So let's draw a quick diagram. So over here, we have a beaker containing sodium hydroxide and we dissolve some calcium hydroxide solid in it. Then after that, the question mentioned it is filtered. So I will filter it. Okay, so filter it, let's take note. Okay, you filter it first. So this side you will notice that the beaker, I tilt it through a filter funnel into a conical flask, and take note over here, the calcium hydroxide solid will be stuck on top as the residue. Okay, it is not it doesn't go through the filter funnel. So what is in the filter funnel now is my filtrate. Okay, it is my filtrate. And take note, the question wants only 25 cm cube of the filtrate. So that's why in my diagram I put 25 cm cube. Okay, even though I did not know what is the original volume of NaOH required used, it is not necessary. The main thing is they tell you 25 cm cube of the filtrate. So take note over here, what you can observe from this is simply NaOH is a base. Okay, calcium hydroxide is also a base. So when a base and a base comes together, there is no reaction. Take note, some of you thought that there's a reaction, but there is no reaction. Okay, the main thing is simply just, I need you to write this down. NaOH is a strong base. It will fully dissociate to give you Na plus OH minus. For calcium hydroxide, remember the question mentioned sparingly soluble. So when you dissociate calcium hydroxide, it must be through a half arrow, and it will give you Ca2 plus plus 2OH minus. So you notice that in the solution, the filtrate, you will have OH minus and you will have OH minus from different sources. OH minus from NaOH and OH minus from calcium hydroxide. So it is quite obvious that it is this OH minus that is going to react with the hydrochloric acid. Okay, so what I can do to this diagram is to write in that the total OH minus ions comes from OH minus from NaOH and OH minus from calcium hydroxide that dissolved. Okay, so based on this diagram, I can work out the solution to all the parts in this question. Let's take a look at A part 1 first. Okay, A part 1, most of you can do it because it's simply just calculate the amount of hydrochloric acid used, and the question has already given you the volume and the concentration. You can simply just take concentration times volume, you get the number of moles, which is 1 times 10 to the power of minus 3 moles. I think most of you managed to get this. Okay, and take note, the next part of the question asks you for total hydroxide ion concentration in 25 cm³ of the filtrate that will react with hydrochloric acid. So take note over here, we know that the total hydroxide ions, okay, in the filtrate will react with the hydrochloric acid. Okay, so over here we know that when HCl reacts with OH minus, it will give us Cl minus plus water, okay, the salt and the water. So in this case, we know it reacts in a 1:1 mole ratio. So the number of moles of hydroxide ions is also 1 times 10 to the power of minus 3. And to find concentration, simply divide by volume. And the volume is 25 cm³. Okay, based on this, we should get 0.04 moles per dm³. Okay, keep in mind that this is the total hydroxide ion concentration. Moving on to the next part. Okay, next part mentions that you are supposed to calculate the amount. Okay, take note, amount over here means number of moles. Okay, of hydroxide ions that is produced from NaOH in 25 cm³ of the filtrate. So remember, just now we mentioned that, okay, when we mix NaOH and CaOH2, okay, when we mix NaOH and CaOH2, there is actually no reaction. Okay, there is no reaction. So after that, if we only want to focus on 25 cm³ of the filtrate, it means that originally I can assume that NaOH given to me is only 25 cm³. Because there is no reaction, I won't use up any of the NaOH, right? So the volume should remain the same. So over here, if they want number of moles, I simply just take the concentration of NaOH times the volume of NaOH initially. That will give me the amount of OH minus produced from NaOH. So it's simply just volume times concentration, it gives me number of moles. Okay, and take note in the diagram, now we fill in some data. OH minus from NaOH will be 2.5 times 10 to the power of minus 4. Okay, and just now we found out total OH minus ions is 1.0 times 10 to the power of minus 3. Okay, take note this is in terms of moles. So based on this, I can find out the number of moles of OH minus from calcium hydroxide. Okay, so very simple, you just take 1 times 10 to the power of minus 3 minus away 2.5 times 10 to the power of minus 4. You can get the number of moles, okay, of OH minus from calcium hydroxide. So let's take a look at the working. Okay, so that's what you do. You take away, you should get 7.5 times 10 to the power of minus 4. Again, take note, the question is asking for amount, okay? Amount means number of moles. Okay? So based on this, we can continue to move on. The next part asks for concentration. And we know that concentration is equals to mole over volume. And we know that the concentration of hydroxide ions that is produced from calcium hydroxide, very simple, just take the moles of calcium hydroxide, divide by the volume. The volume is simply the filtrate volume, okay? This number of moles is present in 25 cm cube of the filtrate, so you divide by the filtrate, you can get 0.03 moles per dm cube. So this is what the question wants. And the next part, once you have the OH minus concentration, the question wants you to calculate concentration of calcium ions in the solution. So take note, we are talking about CaOH2, and we know that CaOH2 tells us that the Ca2 plus is to OH minus concentration will be 1:2. So since now we already know the concentration of OH minus, we can find the concentration of Ca2 plus easily. Okay, just divide by 2 because the mole ratio over here is 1:2. Divide by 2, I should get 0.015 moles per dm cube. Okay, and finally part D, they say write the expression for the solubility product of calcium hydroxide. This is for you to recall how to write solubility product. Okay, so take note of this equation. Calcium hydroxide, it is a solid and it is sparingly soluble to give you calcium 2 plus and 2 OH minus. So the KSP is simply just KSP equals to Ca2 plus concentration times OH minus concentration square. Just a quick recap. If you see a 2 in front here, make sure you square the concentration on top. So very simple, they ask you to use your answer obtained from A part 2 and part C to calculate the solubility product. Very simple, your A part 2 is actually asking for concentration of OH minus, the total. Okay, part C asks you to find concentration of Ca2 plus. So based on this, you can sub in everything and you will get 2.4 times 10 to the power of minus 5. Okay, so based on this, right, just a quick recap. For your CaOH2, when it dissociates to give you calcium 2 plus and 2 OH minus, take note there is 1 mole of Ca2 plus is to 2 moles of OH minus. So it is X plus 2X. Take note that over here, X and 2X is when, let's say, you are in pure water. But in this case, of course, everybody knows that there is common ion effect. We actually dissolve our calcium hydroxide. Okay, we actually dissolve it in a solution of NaOH. So obviously, the common ion is OH minus. And we notice that the concentration from NaOH Okay, the OH minus is 0.01 moles per dm cube as calculated earlier. So remember, this part, when we sub it into the OH minus concentration, we should take 2x plus 0.01. This is the total OH minus concentration, which we found out in A part 2. Okay, so we should sub in everything. Of course, in other usual questions, you notice we always let 2x plus 0.01 is roughly equals to 0.01. It's because for those questions we did not find out what is 2x. So we ignore 2x because we think that it is negligible. But for this question, we managed to find out 2x, so we should include the 2x in our calculations to make the KSP value a more accurate value.